the man, he's the myth, he's the scientist with all the answers and all the questions. It's time for another episode of Alex's Science Corner.
Thank you. Thank you. No, please, thank you.
All right, Alex, what's going on in the wide world of science, my friend?
So, first story is about two ancient galaxies found in a sea of dark matter. Now, a couple interesting things about this story. The astronomers who found this, the way they found it is they used what's known as gravitational lensing. There's some large object between us and the galaxies, and they're able to use that large object to act as a lens so they can see farther back in time. And by able...
In time, not space?
Yeah, both. The farther you look in space, the farther back in time you're looking. Because if you're seeing something from 13 billion light years away, that's 13 billion years old. Or it happened 13 billion years ago.
Wow.
So the farther back you look, the farther back in time you're looking.
Wow. Reminds me of Sam from Quantum Leap.
Not going to be an appropriate analogy, but we're just going to go on past that.
Okay.
So they're able to use this to find... Now, astronomers thought that galaxies at that time were small galaxies just beginning to come together, and they were what we would call dwarf galaxies right now. And what they expect is these dwarf galaxies would come together to form larger galaxies. Well, they found that these large galaxies were forming much, much sooner than they had expected. Because this particular galaxy...
Are these two smaller galaxies combining, or...?
Well, no, what they found was a giant galaxy, when they thought they should only be finding small galaxies.
Oh, okay. So they were misinterpreting what they were seeing?
Their expectations were that if we look this far back in time, we're going to see small galaxies. And then as we come forward in time, we're going to see them come together to form large galaxies.
Okay, now I get what you're saying.
Now they're looking that far back in time, and they're seeing a very large galaxy. They're actually seeing two very large galaxies that are getting ready to collide. And it's also in a sea of very large dark matter, one of the largest cones of dark matter that they've seen. And so there's a lot... For astronomers, this is really cool because it's stuff we didn't see before. It's something that was unexpected. So by seeing these things, that they know that the galaxies were becoming much larger sooner than we expected. Next story is about carnivore brains and how smart, but it's not exactly how smart it is. One of the things about brains are neurons are high energy cells in our bodies. The larger the brain you have, the more energy the brain requires to function. So some animals make up for the fact that they have a large brain by not actually having a lot of neurons in that large brain.
So they're not using as much energy? Is that what you're saying?
Yeah. Because what it is the smarter an animal is, the more they have to eat to be able to function. Because
is that why I'm always hungry?
No, I'm not going to say anything else about it. It's just going to take the fifth on that one right there. So they're examining different types of carnivorians, which is a good part of mammals, and they're trying to figure out what is the neuron density. Because neurons are the parts of our brain that do the connection for the thinking. And comparing different types of animals to each other, one of the things they found is that certain animals have very dense neuron clusters in their brains, while other animals, even though they have a large brain, do not. For example, they found that dogs tend to have more neurons for their brain size than cats do, which tends to imply that dogs tend to be smarter than cats. Now, one thing they did find is, for example, like bears have the same number of neurons for their brain as cats do. So even though their brains are 10 times larger, they have the same amount of neuron cells in their brains as a cat.
Which means?
Well, which means that their guess is probably that cats are probably as smart as bears. Or bears are as smart as cats. One of the things that they found is that...
I thought bears were pretty dumb, aren't they?
Well, having the brain 10 times the size of a cat, yet being as smart as a cat, that would imply
They
what
are
you
pretty
just said.
Dumb.
Yeah.
No, they're not.
I'm sounding like
now,
a
one
bear.
of the things... It's bare necessities.
Jungle
Yeah.
Book? Is that Jungle Book?
Yes.
Yeah.
One of the things they found is what they were expecting is that carnivore animals might have better brain or neuron densities than prey animals, but they found that that was not the case. Prey animals can have as high or higher brain densities than carnivores can. One of the more interesting ones is one of the highest brain or neuron densities was like raccoons. Raccoons are really, really smart for the size of their brains.
That's Rocket.
Yes, exactly. Which is why you see raccoons going around building spaceships.
That was Guardian of the Galaxy.
I saw the trailer. Yeah.
So he knows everything about it.
I liked the second one. That was cute.
So again, it's one of those... the challenge of this story is that, or the thing about this story is, they're finding that an animal, the intelligence of the animal is not based on the physical brain size. It's not going to matter so much about whether it's a prey animal or a predator animal that's going to affect brain size. They actually haven't figured out something that they can say, this is a pattern that will tell you whether it's a smart animal or not. They really have to go in and examine the brains and figure out the neural densities. But the thing that makes them smarter is the amount of density of the neurons compared to other cells in their brains.
Okay. Sounds
Got it.
reasonable.
Yeah.
All right. Bobby, no questions?
Nope. Well, because you were saying when he was talking about prey animals, I'm thinking eagles and hawks are, their brains relatively have got to be small, but I mean they're pretty smart when it comes to hunting and
crows are considered to be extremely intelligent birds, which are much, much smarter than chickens, and chickens are considered to be incredibly stupid birds. Again, brain size is about the same, but the neural densities, the amount of neurons in the brain, there's going to be a vast difference between those two.
Okay. All right. If you have any questions about these two stories that Alex just what's the word I'm thinking?
Related?
Related. Thank you.
Okay.
My neurons aren't as dense as they normally are. And if you want to
They're
give us...
just not awake.
No. If you want to give us a call, feel free. You can ask Alex any question, or you can ask Bobby a question, or you can just say hello at 203
837
99
24.